In this video, I'm going to show you how you can make a calculator like this. It's just a spreadsheet that'll automatically calculate your either converting an x-score to a z-score or a z-score to an x value, or if you just want to map out the entire scale of your values, you can do that too. And I'm actually going to use a problem from the homework. Okay, here's the problem. Let's read it. The time to complete an exam is approximately normal with a mean of 50 minutes and a standard deviation of 8 minutes. The bell curve below represents the distribution for testing times. The scale on the horizontal axis is equal to the standard deviation. Fill in the indicated boxes. The scale on the horizontal axis is equal to the standard deviation? That sounds really weird. What we're really supposed to be doing is filling in these boxes with the mean in the center, and then if we add one standard deviation, we get 58. Add a standard deviation again, and we'll get 66. And add a standard deviation again, and we'll get 74. Subtract a standard deviation from 50 to get 42. Subtract a standard deviation a second time to get, let's see, it would be 32, 34. And one more time, we'll subtract standard deviation and get 26. Okay, now I want to show you that my calculator is going to do this for me as soon as I change the mean here to 50 and my standard deviation to 8. So notice that my scale down here just calculated to give me all those values that I already got. So now, would you like to learn how to do this? Let's do it. Let's clear everything out here so you can start from scratch, and you can set up the structure first if you'd like. You can use the colors you like and do all the formatting you want to do. So the first thing is get something, use a mean and a standard deviation that you can work with easily. So let's say I use 0 for the mean and 1 for the standard deviation. Now, my z-score scale should always be 0 in the center corresponding to the mean, then 1 because it's one standard deviation above the mean, 2 and 3. Then going backwards from the mean, -1, try that again, -1, -2, and -3. That's easy. Now for the x scale. So I've said that my mean is 0 and my standard deviation is 1. And the reason I did that is because then if I program the blue cells correctly, they'll match my z-scores exactly. So it makes it convenient for me to do that. So what I'm going to do is I'm going to start with the mean and make that an absolute reference. Then I'm going to add the standard deviation and make that an absolute reference. And then I want to multiply the standard deviation times the z-score that corresponds to that cell. So right above it there. Leave that a relative reference, not absolute, that last part. Okay, now I can copy this right and left and see that it matches up with my z-scores. Now to test it further, I'm going to change my mean so that it is something easy like 100 and a standard deviation of 1. So notice that it just automatically recalculated so that the mean of 100, if I add one standard deviation, I get 101, add another standard deviation, 102, and so on. Same thing going backwards. So this is set up to now work with any set of mean and standard deviation. Next, I'm going to set up this section to receive a typed in x value and spit out the z-score that corresponds to it. So let's do something that we know what the z-score should be. Let's do 115. So say I'm going to use 115 and I want to convert it to a z-score. So I'm going to use the z-score formula that's shown right there. Zoom in a little bit. And I'm going to do parentheses, the x value minus the mean, close parentheses, divide by the standard deviation, and press enter. So that came out to be 1 like I knew it should. All right. Now I'm going to do that the other way around. Let's say I know I have a z-score of 1 and I want to know what x value that corresponds to. So I'm going to use the formula right there. X equals the mean plus the standard deviation z times. All right, so here we go. Equals, I'm going to take the mean plus the standard deviation. How many times? Z times. And there you go. It took 1 and made it into 115. So now no matter what I put in here, 0 and 1 or 10 and 5, notice that everything, this one looks a little odd though. 21, does that make sense? Oh yeah, because I have 115 there. So let me do one that's a little better, like, let's do, how about 5? Would make -1, right here. And if I put in, say, -3 here, it corresponds to -5 on the x scale. All right, then you can also set it up for empirical rule. The empirical rule works only with normal distributions. And the way I'll do this is I'll just recall, first of all, that with normal bell-shaped distributions, we expect 68% of the values to fall within 1 standard deviation of the mean. 1 standard deviation. So the values would be from 1 standard deviation here below the mean and 1 standard deviation above the mean. For 95%, remember that's 2 standard deviations. So 2 standard deviations below the mean would be this cell, and 2 standard deviations above the mean would be this cell. And I'm going to change my mean to be 100 and my standard deviation to be 10, just to make it a little bit easier to see what's going on here. So I would expect 68% of my values to fall within 90 and 110, because that would be 1 standard deviation in each direction from the mean of 100. Standard deviation here is 10. 2 standard deviations below 100 is 80. 2 standard deviation above 100 is 120. So 95% of my values should fall within that range, and 99.7% for 3 standard deviations out. So 3 standard deviations below the mean and 3 standard deviations above the mean. And that's it. Now this thing will work no matter what I put in for my mean and standard deviation. Have fun.